Okay, what we're going to do in the second part of this lesson, which is lesson 7, is look at what we call hydrates. And what we're going to do is find out the percent composition, which you already know about, of these compounds that we call hydrates. Well, all a hydrate is a compound that contains water molecules. Now, it's a little bit more complicated than that, but that's what we're going to leave it with right now. So the formula for the hydrate we're going to look at down here is copper sulfate, or copper 2 sulfate, penta, which is 5, hydrate. So what you can see is the formula is a little bit different than what we're used to. We've got a coefficient in the middle of the formula, and that dot. Well, all that dot in chemistry means is that these 5 waters are attached to that copper sulfate. So up here you can see a diagram of the actual compound. You've got your copper and then the sulfate, SO4, and then you've got 1, 2, 3, 4, 5 waters attached to that copper sulfate. And that's basically what a hydrate is. Okay, so what we want to do is find the percent water in a hydrate. And we use the same process that we used earlier when we were finding percent composition of compounds. We're going to take the part over the whole times 100, and then we're going to put our percent unit there. So the part that we're trying to find is the water part. And as you know, we use molar masses. So to do this, the molar mass of water, 2 times 1 plus 16 is 18. But we've got 5 waters. So what we need to do is take 5 times the molar mass of 1 water to account for all 5 of them. And then in the denominator, what we need to do is add up the molar mass of the whole compound. So we've got 64 for copper, 32 for sulfur, 4 times 16 for the oxygens. Now the other thing we have to do is include the water part because it's the mass of the whole thing. We're going to multiply by 100, and that would give us 36%. So 36% of any chunk of copper sulfate, so let's say we have a big chunk of copper sulfate here, 36%, which, I don't know, maybe around there, is going to be made up of water, and the rest of it then would be the copper sulfate. So what we want to do is figure out in the lab, how would we figure out the percent water of a hydrate? So let's take a look at that. Okay, let's go over a few terms here, first of all. The hydrate, like we said, was the whole compound, the copper sulfate, dot 5H2O. What we're going to do is we're going to put that whole compound in a crucible. And you know what crucibles are. We used them when we did the magnesium lab. And then what we're going to do is apply some heat from our Bunsen burner. And what that'll do is it's going to drive off all of the water. In essence, it's going to evaporate it or boil it, however you want to look at it. Either way, it's going to drive off that water. Once the water is driven off, the only thing that's left is the CuSO4. We refer to that as the anhydrous salt. Salt is another word for ionic compound. Anhydrous means the water has been driven off. So what we're going to do is we're going to put that whole compound in a crucible. We're going to burn off all of the water, and then what we're going to do is be able to determine the percent water in the compound. So let's say, for instance, we had a compound, a hydrate, and let's say its initial mass was 5.95 grams. And that's for the whole thing. Well, let's say we applied some heat to it and we burned off all of the water, and when we reweighed the compound, it was 3.81 grams. So if we wanted to know how much water was in the compound, if we subtract those two values, we would get 2.14 grams of water. So if we wanted to figure out what was the percentage of water in that compound, what we would do is take the water part over the whole thing times 100. And if we do that math, we're going to get 36. And don't forget our percentage sign. So we would have found that this compound is 36% water. And that's a good thing because that matches what we found in the other slide. Well, sometimes you're going to be given a compound where you're not going to know what that coefficient is, and what we'll want to do is figure out what it is. So let's just assume that when we went to find this compound, we did not know what X was. We had our initial mass, we had the mass when we drove off all the water, and we were able to find the water, or the mass of the water, and that allowed us to find the percentage of water, but it didn't allow us to figure out what that value of X is. Now with this compound we know that it's 5, but like I said, let's assume that this wasn't given. What we can do is use this information to calculate what that value of X is. So let's go to the next slide and we'll do that calculation. Okay, so like I said in the previous slide, we have this compound. So we have this compound and we don't know what that value for X is. However, we do know that the compound is 36% water. So to solve for X there, we're going to set up a math equation. And what we're going to do is use the molar masses of our compound here. So we want the part over the whole. So the part here is going to be X times 18. In other words, it's the molar mass of water there. 2 times 1 plus 16 is 18, but we still don't know what the X is. And we're going to put that over the mass of the whole compound. So if you remember, the copper sulfate part of this compound is 160. That's 64 plus 32 plus 4 times 16. But we also have to add the water part, which is X times 18. We'll multiply by 100, and we know that all of that equals 36%. So now all we have to do here is solve for X. So the way I would approach this is I would rewrite this equation 18x over 160 plus 18x. And what I'm going to do is I'm just going to set this equal to 0.36. All I did was divide both sides by 100. That way I get rid of that, and I get rid of that unit, and I have just the value 0.36. Now it's a little bit more manageable. So what I'll do is I'm going to multiply both sides by the quantity 160 plus 18x. So if I have 160 plus 18x, that's going to cancel out, and I have 18x is equal to, now I need to distribute that. 0.36 times 160 gives me 57.6, and I'm going to distribute that, and I'm going to get 6.48x. I'm going to subtract 6.48x from each side. Sorry, it's a little sloppy. And that's going to give me 11.52x is equal to 57.6. And if I divide both sides by 11.52, I'm going to get x is equal to, you already know the answer, is going to be equal to 5. So again, all we did here was originally we found our percentage of water, and then we solved for x by using our molar masses for the part, or the water part, over the whole. Okay, so here would be your typical problem. We have copper chloride dot X H2O, and we don't know what the X value is. So it says in the lab you find the hydrate weighs 0.235 grams. So we have that. You burn off all the water by heating the compound and find the mass to be 0.185 grams. So now what we can do from this data, we can solve for X. So let's subtract that value, 0.235 minus 0.185 gives us 0.05. So that mass there is the whole compound. That mass is just the anhydrous salt because we've burned off the water, So that mass, when we subtract those, has to be the mass of the water. So what we're going to do is we're going to take our water part over the whole thing times 100, and we're going to get 21.28. So that's our percentage of water in this compound based on our lab data. So now what we're going to do is we're going to take the part x times 18, because what we're trying to do now is solve for x, over the whole. We have 64 for copper plus 2 times 35. Now I always write the molar mass of chloride, chloride as 35.5. And then we have plus x times 18 times 100 is equal to 21.28. Alright, so let's simplify this a little bit. We've got 18x over 135 plus 18x. Again, I'm going to divide by both sides by 100, so I can write that as 0.218. So we can take 18x is equal to 0.2128 times 135 plus 18x. Let's distribute. So we get 28.73 plus 3.83x. Put our 18x over here. Let's subtract 3.83x from each side. So we get 14.17x is equal to 28.73. Divide each side by 14.7 and we get 2. I think we get 2.02, but that's close enough. So that would be your typical problem for solving for an unknown value for x using lab data. So in this process, there's really two things we're trying to do. Figure out what's the percent water of a hydrate, and when given an x times H2O, we can solve for that x. So you're going to do a bunch of practice problems, and you can use this vodcast to act as review. Till next time.